No, seriously, the methods section of a scientific article should tell the readers what did you do so we can try to do it too. Unfortunately, the method sections are often overlooked and undervalued, and they end up being like, we did this according to this, and then we did this according to this, and then we're back and we did this according to this, and you end up in like going down all these rabbit holes of trying to find the original citation. And the methods that turns out being from a really, really long time ago that's not even digitized. And so today I want to tell you more about how to make the most of method sections, how to make good method sections for yourself, and also like why method sections matter so much. So a lot of people kind of overlook these. They're often hidden in like the supplement part of the paper. You often have to download them as a separate thing as opposed to actually being in the article. I found science is like the worst for these, like the science journal. Sometimes they have like the methods in the notes. It's really weird. But anyway, method sections are super duper important, especially when you're trying to start out and design experiments like I'm in the phase now that I'm in. And so I want to tell you more about how I'm going about things, and some of the values and things about methods papers, as well as other things about methods that you can get information on and various things like that. So let's dive in. So, method section. For anyone who is unfamiliar, these are sometimes called experimental methods and materials. There's all these different names. Sometimes they're in the middle of a paper, sometimes they're at the end of a paper. Often there's like a short version at the end, and then they have like supplemental methods, and that's where the real thorough methods are, if there are more thorough methods. But even then, they often are citing other papers. And it's okay to cite other papers, and you should cite other papers, but don't just say we did it like these people, especially if there are modifications. And so we'll go into this in a minute. If you want to, the method section, basically the authors are supposed to be telling you what they did in a way that other people would be able to recreate the experiment. Unfortunately, they don't often give like as much information as they really should. And I get the sense that those parts of papers probably don't get as much proofreading, as much care, as much attention. Even though these are super duper important parts of an experiment, this is like the core meat. Like, I just love method sections. And so often these are like my favorite parts of papers, especially when I'm trying to plan out my own experiments. So right now I'm in the process of trying to plan out some experiments. And so the methods sections are super duper important to me. And so I've been reading these in depth. For other articles, maybe you don't care about the methods so much. Maybe it's something that you're like, there's no way I'm going to be able to recreate this method that uses all this technical equipment. So I'm not going to worry about those technical details. So it's all article to article, depending on your desires and how it'll fit into your research. And so when you're doing research and reading papers, you always want to be thinking about how would this impact my research? How can I take advantage of these different things, and that sort of thing. Methods are also important to make sure that the methods are actually compatible with how they are saying that they're interpreting the results. So if the concentration of salt, say, is super duper low and they're saying these things are binding to one another, then you can be kind of like suspicious. Well, what if you raise the salt concentration? When you raise the salt concentration, it's harder for things have less affinity for another typically, because the salt kind of competes for the binding partners. And so when you have a higher salt, then you're going to get more specific. Only the stronger binding is going to be able to stick. So if you look in the experiment section, you can see like, okay, well, what is the salt concentration? Well, you can look at, are you in the kinetic range for some assay, or the various things. So various technical details that you'd be able to find out from information in the methods section. And so this can be really important to interpret the results accurately and see if they interpreted the results accurately. Okay, so but say you want to look at methods because you want to do a similar experiment. If there is a core protocol, often when people develop new techniques, then later, if this technique catches on or that sort of thing, they'll have a specific like methods or protocol paper, and often there are multiple versions of this. There are journals that are dedicated to methods. There's like Nature Methods, there's a bunch of methods. There's this thing called JOVE, it's like Journal of Visual Experiments or something. And they actually have like videos of protocols. There are a lot of really great sources up there. Sometimes you can find some posted on ResearchGate, various things like that. But these methods or protocol papers are going to be the most detailed. They're going to have way more detail than you would normally find in a paper. We're talking step-by-step details, and be sure to read the notes. They often have like notes and they'll be like asterisks, or they have like little like end notes. These are going to be super duper important. These are where they tell you all of those little like, oh yeah, you have to keep this at room temperature, or oh yeah, don't use this brand, you know. These are really important things, and so make sure you read those notes. Okay, so these methods and protocol papers are really good for the core of the experiment, but often you might want to make modifications, or speaking of modifications, these methods papers might have been made, or the original paper, they typically have more description than they do in subsequent papers, because in the original one, they have to describe things more. And then in the later one, they'll just be like, we did it like we did in the original one. But often what they'll say is we did it like we did in the original one, but we made a few modifications. And so often those initial protocols are more detailed, but they're not always up to date. So you want to go to like the latest article that uses the technique, or the latest articles that use the technique. So you can look and see where this technique was cited. And then these newer papers will say something like performed as an X and then cite that original, but with the following modifications. So you want to be able to find that original to get the like core method, but then you also want to make sure that you make note of the modifications that were made. These modifications, sometimes they're modifications that are just specific for the people's experiments, and it's not something that really matters to you. But sometimes these modifications are things that improve the overall technique. Maybe make things faster, make things easier. Maybe you can skip the gel purification step and use a column-based method, things like that. And so you want to know these sort of things. You can also get this sort of like up-to-date knowledge by talking to someone who is uses the technique or has recently used the technique. And so this is really great when you're at a place like at a research institution where there's other labs that use these techniques, and then you can go talk to people and even shadow them. And so that's what I've been doing, and I'm really grateful for that. You can also, if you don't have access to people doing the technique, or even if you do, don't be afraid to email the authors of the paper if you have questions. So often when you're talking about these articles, the corresponding author is going to be like the last author. So this is the person that you're going to email, and they'll have the email address provided on the article, like on the page for the article or on the printed version, whatever you're looking at. You can email them and ask a question. Often they'll actually they might forward your email on to like a student in their lab who was actually doing the experiments or that sort of thing. But hopefully you can get some answers to your questions. Speaking of getting answers to questions, Twitter is an amazingly good source of scientific answers. So I go there when I have questions. Also Google, Reddit sometimes. These can be super duper helpful, and I'm totally serious. There are a bunch of people out there that have this expertise and that are really, really helpful. But they're like these questions that you're able to ask, these weird random questions that are really specific, but these people do these things every day and that sort of thing. And they'll be happy to answer. Okay, but sometimes there are things that you should be able to kind of figure out yourself. Not that if you can't figure out, it's like a big deal. I mean, like, don't like judge yourself for anything, but if you understand, it's really important that you understand what's going on at each step and why you're using each reagent. So like those chemicals that you're using. This is going to allow you to see if there are specific steps that you might be able to exclude or modify. So like I said, sometimes people use experiments for very specific purposes. And so they're looking at they'll be looking at multiple things, say. Maybe you don't want to look at one thing, so you can exclude that. Or maybe you want to look in a different area of the cell, so you can modify things that way or whatever. And so if you recognize what is happening at each step, then you can know when you can make changes, when you can't make changes, and how you can adapt the protocol to the questions that you want to answer, and not just the questions that they wanted to answer. Okay. So with the method sections, what should be in method sections? They should be written so that others can reproduce the results, preferably without having to go down one of those rabbit holes, as I was mentioning, where people are often citing papers, citing a super old paper that's not digitized. Sometimes, and then if you do cite a paper in your methods, make sure you read that paper and it actually has the methods. I've gone to places before where it says we did it like we did it in this paper, and I go to that paper and they didn't even do that method. So make sure that you actually read the paper and that you are citing the right paper, and that you're not just citing a paper, that when you go to that paper, it's citing another paper. So many times this happens, so many times. Okay, another thing. So tell me where your proteins come from. So as a protein, like coming as a protein biochemist, a huge pet peeve of mine is that papers often use like recombinant proteins, or so proteins that were like, the instructions were put into cells and the cells made the protein and then those are purified out. But they don't say like if they purified them or if they bought them. Either way, you should tell us. And if you did purify us, tell us how. So often they'll just say like, we purified these proteins, or like we purified it using nickel affinity or something really non-specific. We want details. We want to be able to recreate it. Tell me your buffers, tell me what type of columns, tell me all the goodies so that I can do it too. And now to your antibodies. So antibody quality can vary. And so sometimes antibodies are going to be more or less specific. And so you can, and then sometimes there have been papers where it's like, oh yeah, we found this antibody that's been used really widely, isn't as specific as we thought. So give the details of the source of those antibodies, as well as controls for the antibodies. Okay, so when you are looking at a methods section and you are going about trying to develop your own methods. So often this is going to involve looking at those older articles, looking at the newer articles, and trying to kind of piece everything together. So unfortunately, those methods articles are often written a while back, and then you have these modifications to it, but you still want the super detailed one. And so you're going to have to kind of mix and match and write up your own protocol. And so taking into account that original method and any modifications, either those that you read about or those that you want to introduce, probably try it the way that they do it first before you introduce any wild modifications, just to make sure that you can recreate the original results. On your method, I like to note the pause steps and the long incubations. If there's going to be steps where you have to start one thing when another thing's going or that sort of thing, it can be helpful to make an experiment schedule of when to start each step. It's also helpful if you're doing like a bunch of timed steps and then you get kind of lost. If you like checking off, okay, I did this, I'm doing this now, so this is next. Make a list of all the things you will need, the chemicals, the equipment, all of it. See what you have and what you need to purchase. Often in some articles, they'll have the brand, the authors will put the brand or even the part number. And so this can be helpful to see what they used, as well as any of the specifics of what they used. But note that you can usually use alternatives. So if they use one brand of a concentrator kit, you might be able to use another brand of a concentrator kit without any problems. And this is one thing that you might see a note on in the methods, in like a methods protocol. Sometimes different brands might have different nuances that the papers will tell you about. Before starting, make sure you have everything you need, including all the solutions you needed to prepare. And so this is part of why it's really helpful to write up your own detailed protocol, because there could be, when you're looking at the methods sections, they're really, really condensed. And it can be easy to kind of forget, oh man, I needed this thing here, because you have like 20 different things in this one sentence. And so you want to make sure that you have all of that before you go in. If you're new to a lab, so I've been trying to figure out what we have, what we don't have. So you want to make sure you know where everything is, and don't assume that the new lab has everything that your old one did. So different labs focus on different things. And so we have a lot more things in like the chemically side here. And in my old lab, we had more things focused on protein purification and structural stuff. So make sure that the lab has what you think it has, and you know where everything is before you start out this experiment and do a bunch of steps and then realize you don't have everything you needed. So take your time, especially the first time. This can take a while, so don't worry if it takes a while. You need prep time. Totally good. And it's going to help you prevent you from making mistakes. So hope that helped, and make sure you make your methods matter.